Welcome to the 21st episode of Byte-Sized JavaScript. In the former episode, we have set up a very simple React project and configured Webpack to bundle our dependencies. And in this episode, we'll continue from where we left off. We'll first add some required dependencies for Webpack to work, and then launch our React dev server to actually see a dummy Hello World web page. And then we'll gradually convert it to a more meaningful application, to something that people can actually use. So let's begin. First, I'll need to add Webpack, Extract Text Webpack plugin, HTML Webpack plugin, CSS, Style, and Sass loaders, File Loader, Node Sass, and URL Loader as dev dependencies. And since we are using Babel to transpile our files, we'll need to add Babel core. We'll probably need to add Babel eslint to coordinate with eslint configuration that we have. We need Babel Loader, Babel plugin Istanbul for coverage reports, and Babel polyfill if we want our code to run in older browsers. We'll need to add ECMAScript and React Babel presets as dev dependencies. So that's a mouthful, but we need them, so we have to add them. And for linter configuration, I'll use Byte-Sized JavaScript conventions, which is located in the module eslint-config-jsbytes. And we'll also add the necessary eslint plugins and loaders for Webpack, Babel, and React as development dependencies as well. Then we'll create a Babel RC file to define our transpilation rules, and we'll also create an eslint RC file to define our linting rules. For the Babel preset, we'll use ES2015, and we'll set modules to false, because Webpack will take the responsibility to generate the modules from Babel. So we don't need to do this twice. Webpack will be handling the module generation for ourselves already. We'll add React for JSX support, and we'll add stage 0 to enable all ECMAScript features that Babel supports. And as a side note here, on a production environment, it is not wise to use this stage 0 dependency. If this was a production project, I would have taken a more conservative approach, and I'd probably include a stage 3 preset and selectively cherry pick and add any additional plugin that I might need on top of it. And for linting and validation, I'll extend ESLint-JSBytes/React to enable React-specific linting rules for our JavaScript files. Then I'll create bin/watch.sh to run Webpack in watch mode, and then add it to our package.json scripts as well. And then I'll run the code. And we see that it generates our index.html, updates the title of the page, and injects the bundled resources that we need directly into the page. I'll also create a bin/serve.sh to run webpack-dev-server and mark everything under this bin folder as executable so that I can run them as npm scripts as well. Also, we need to add webpack-dev-server as a development dependency, and once we run npm run serve, we'll see the same page that we initially created, but now the text we see is a React component. To prove that, I'll change this text and observe that the text also changes on the page as well. Since we have an initially working version, I think it's a good time to commit our changes, and I'll do so. So we'll be writing some HTML, but before that, let us create a quick UI mockup before writing actual HTML. So our UI will look something like this. We'll have columns where there will be tasks or cards, and we can move one card from one column to the other back and forth. And I label the columns as best intentions, to do, in progress, and done to specify the stages of a goal in mind. And a goal will start its life cycle as a best intention and move across these columns until it gets done. And I'll also need something like a model window to edit the details of the particular goal at hand. And it will roughly look something like this. Since we have 4 columns, I'll add 4 components under components/columns. They will be named as best intentions, to do, in progress, and done. And I'll also add index.js files to all of these folders as entry points. And since all these columns look more or less alike, it makes sense for them to be composed of a more generic column, which I call a base column. The base column will have a heading and a bunch of child elements. And the reason for these red squiggly lines that you see here is because we haven't done any PropTypes validation for these properties. And defining prop types helps the development runtime warn us against any missing or invalid properties that we might be missing or we might be passing as an incorrect type. Like, for example, I need a number and I'm passing a string, or I need a date and I'm passing a number or something like that. So it's a useful feature that React provides us as a development utility. And when you create a production bundle, all the prop types validation is removed from the code. So this doesn't have any performance impact. It only helps you develop your code in a more predictable and more robust way. And let's go back to our components. They will use this base column and then pass heading as a property and this HTML as a children to our base column. We'll do it for other columns as well. And now we can add those columns to our application component. Then I'd like to change the headings of these columns so that we can differentiate them visually. And now we can see them on the page as different titles and sections kind of. Next we need to add some styling, I think, to make them look like actual columns. And for that I'll first just create a sample CSS and add a background color to the body element and import it in our index.js to see if the style sheet rules are applying to my page as well. And it looks like they do. Now we can add a bunch of extra style sheets. And I may also need to pass a CSS class to the base column component that the columns contain. So I'll define it as a prop to the base column and pass them as class names on the separate column components one by one. And here I'm following BAM conventions, though it's not that important for our discussion. You can use any kind of styling convention you like in your projects. BAM stands for Block Element Modifier. For more information about BAM, you can go ahead and read this page, and I strongly suggest you do so. And to continue our CSS development, I'll also add some background colors to the columns, and also I'll import the CSS file for these columns as well. And to position the columns vertically, I'll use a flex layout. And you can read more about flex layout on this page that you see here too. And since the layout looks more or less fine, it's a good time to push another commit as well. Next, we'll do some database integration. And as I said, we'll be using Firebase as our cloud NoSQL database. And that will have to wait for the next episode. In summary, in this episode, we installed the dependencies that Webpack needs, then Webpack bundled our files, and then we ran webpack-dev-server to serve our React application. We briefly talked about prop types, PropType validation, and how using type checks makes front-end development less error-prone and more predictable. Then we configured eslint to validate our JavaScript. We talked about BAM, Block Element Modifier, as a CSS organization methodology. We used the application Skech to quickly create a UI mockup. We then created a few additional components that we needed and we composed them together. We used props to pass attributes down to child components, and also we used Flexbox to create a flexible 4-column layout easily. And in the next episode, we'll continue our journey about React by connecting our page to Firebase to hydrate our application state with some real-time data. So until then, may the source be with you.